Okay, so there are a couple of capacitors here that we really need to swap before we start using the 2A5. That's here the cathode bypass cap. This one, the 10 nanofarad capacitor, this guy over here, and that one as well. Because this, it's not drawn here yet on my schematic, but this will have the B plus coming over here on this side of the capacitor, and that will feed the next tube. See, it is on this diagram. So you see we have the B plus coming in over here. It's going through this 100K resistor, and there we have C13. That's the 10 nanofarad capacitor that I was talking about. So this will have a dropped version of the B plus, and there it goes to the plate of the 2B7. So we really want to swap out that one as well now. I think that's about it. Those are the most important ones. Now let me show you here this circuit, because there is a general peculiarity about this radio, and it's most prominent here. Let me show you. So remember, this was our box with our hum cancelling capacitor and the cathode bypass capacitor. So this side of the cathode, this side of the box, this tab is the cathode bypass capacitor, and as you see here, it is connected to the cathode of the 2A5. That's this black wire over here. Then it goes through the capacitor and here to ground. And then we have the cathode resistor. And this piece of wire over here, it's the resistor. This is resistive wire. And because see, that is simply connected directly here to ground. So this wire in here is a resistor. And there are multiple places here in the radio, see, like this one as well. That's also a resistive wire. It's not a resistor per se, but it's resistive wire. The drawback of this is that there are some other places as well. The drawback of this is that I don't have any component values. I only have here what John Coster wrote on his schematic, namely that this should be 350 ohms, but I'm not sure. We can desolder this and measure, because I don't think these things will change their component value. See, you can even see it over here. Let me bring you in a bit closer and let me focus. Come on. Yeah. See over there? See, you can even see the wire wound sticking out. See? It's like a potentiometer, like the inside of a potentiometer. So let me desolder this, and then I'm going to take this capacitor out of circuit. But it'll take a bit of work to rearrange this, because I need to desolder this resistive wire as well, and I need to find a way to mount this. It's not going to be straightforward. Okay, so this one is done. This is the new capacitor that I put in. So that was a 0.5 microfarad. I replaced it with a 0.47 microfarad. This resistive wire here, I put some heat shrink on the edges to give it a bit of extra support, because it is quite fragile. As you start desoldering it, if you start moving it around, it comes loose from these edges here. And yeah, it just looked very fragile. So I put some heat shrink here on both ends. And this is the original wire here that is simply used. So that's the first one done. Now let's see, what's the next? Maybe this guy over here. That's this capacitor, which is going from the plate of the 2A5 to this switch. That's this switch on the side here. And that's a tone control switch. Yeah, that's a 200, I say 200 picofarad, but it's 200 centimeters, so that one is next. So 200 centimeters times 1.11, that's 222 picofarad. Okay, these have been replaced. This one is a 220 picofarad. So I took a silver mica one, 500 volts, and I had to extend the leads a bit because it's quite a distance. And like I already said earlier, that's this guy. And then this capacitor over here, that's that one. This connection, that's the connection for an external speaker. That's these two plugs over there. And it's basically across these two plugs. And yeah, as you see, the entire circuit is extremely basic. See, so the connection for an external speaker is just a plug between the plate and I think that's a screen grid, right? So just like on the same place where the internal speaker is connected, it's really extremely simple. So, but that means that, like I mentioned earlier as well, you have the B plus simply on one of the buses here on the outside of the radio. On both, actually. See, you have the B plus on this side and the plate voltage on that side. So yeah, it's interesting. Now, I think we are done here. I think I have replaced everything that I need to. No, this one I still need to do, the coupling capacitor towards the next stage. Okay. Okay, and that's this one. So that one is also done. Now I believe that we are ready to put in the amplifier tube, the output tube. Let's get the 2A5. So here it is. That's the 2A5, see, output tube. Okay, so I've got the datasheet here. As you see, just like I mentioned earlier, the heater is between the first and the last pin, and then pin 2 is the plate, pin 3 is the screen, pin 4 is the grid, and pin 5 is the cathode. These are the characteristics. What is funny here is that they state a maximum of 250 voltage on the plate. That's quite conservative, because if you look here on a different schematic, they state these are typical operating conditions, but maximum ratings 375. So I would say that these are also typical operating conditions and not maximum ratings. But what is important to know is these parameters, so then we can check afterwards if they are more or less in the correct ballpark and if we don't have anything going wrong. So grid voltage minus 16.5, because we are using it in pentode mode, obviously. Plate current, screen current, power output 3 watts. So we will have a look at that later when the tube is back in the in the chassis and when the radio is powered up again. But first I'm gonna test it and see if it is still fine and if I don't need to put in a new one. Okay, I've already set all the settings correctly for the tube. So as I said, on pin 1 and pin 6 there is the heater. So we have filament on pin 1, ground on pin 6. 7, 8 and 9 are not used, so they are tied to ground. Pin 2, that's 8. 8 is the plate. Pin 3 is 6. 6, that's the screen. Pin 4 is set to 4, and that is the grid. And pin 5 is set to 2. And 2 is ground, so it's, the cathode, basically. Then we have filament voltage, 2.5 volts. We have the grid bias set to minus 16.5. And as you see, like we said in our datasheet here, it's also minus 16.5. We have the plate set to 250 and the screen set to 250. And that's exactly also what they recommend here as a operating value. And then they say we should measure, my manual for the tube tester here says we should measure 34 milliamp, and that's also what we got here, 34 milliamp. So everything is set. So let's hit it. The scale is at 100. It will take a while before it starts conducting, obviously. So we're expecting 34. Nothing yet. The filament is lighting up. And it's coming up. It's coming up. We're at 20. Still rising. 24. Still rising. 25. I think it's more or less done at 25 milliamp instead of 34. Let me write that down somewhere. Okay, so I've let it run for a couple of minutes and it's now at 26. So let's take 26. 26 divided by 34. It's 76%, which is acceptable, clearly used, but still acceptable. As long as we are above 70-75%, the tube would be good. So definitely still usable, not a fresh tube though. Now, what is also important, or maybe even more important, is the mutual conductance. So we should have 2.5 milliamps per volt. So let's see. If I go a half a volt lower, I think this is more or less half a volt. Then we have 27. Now this is a very rough measurement. The reason is because this tube tester, as soon as you go over a grid bias of 10 volts, then you have to multiply it by 5 and this dial becomes quite inaccurate. So I think this is half a volt lower, so we're now at 27 milliamps and this should be half a volt higher. It's not that great though, I think 1.5 more or less. 1.5 milliamp per volt, and then I'm being generous even. So 1.5. Oh, what just happened here? Something happened in the tube tester. Tube tester just turned off. Okay. Let me unplug it. Did my fuse blow? Yeah, the fuse blew. Maybe I've been just using it a bit too long. I've been letting it sit for too long, probably. Let me get this up and running again. I think we are here at a mutual conductance of about 60%. So this tube is definitely weak. It still works, but it's weak. I don't have a 2A5 spare, so I might pick up one in the future. Oh, it's really hot. So let me let this cool down and then get the tube testers, change the fuse here. I don't know what happened here. And then we can check it again. Yeah, we're back in business again. It's just a fuse that blew here on the tester. I don't know why. Maybe it's just because it's drawing too much current for an extended period of time. It's a 1 amp slow blow fuse, so I don't know. Anyway, the tube is still working fine. It's reading the same value. So I'm just gonna turn it off and then we can put it in the radio and see what happens over there. Okay, here we are for the big moment. I moved the radio a bit to the right, so you can also now see the screen of the dim bulb tester. So here you should be able to see what is the voltage is that is going in. It's quite small, so I don't know if you will be able to read it. But anyway, I will mention what I see over there on the screen. This is the B+, and this is really funny because I'm just taking it here from the radio, because this is the phono input. I think one of the two outputs is connected directly to chassis. And here I'm not taking directly the B+, I'm taking the plate of the 2A5, the output tube. See, so that's this connection. So I'm connecting here directly to the plate into that banana plug, and then the B+ is going through the transformer, the output transformer, which is acting as a load here as well for the tube. And so I'm measuring it after the the output transformer basically, because I really want to know what is on the plate of the 2A5. And then we can go a bit more in detail into some other measurements. But yeah, let's see if we power this up, what we get. Now I'm gonna put a 15 watt bulb in here for the moment, just in case I did something wrong. And I have the speaker here just out of shot, and I hope that we hear some hum in the speaker. I'm not sure we will, but I mean, that's the idea, right? One other thing to mention, I always have been saying that the volume control has the on-off switch connected to it. That's not, strictly speaking, not really true, because that's not the volume control, that's more like a gain control. We will come back to that later. That is doing nothing in the circuit that we have here. This volume control over here, man, it's always washed out. This volume control over here, the 750K one, that is this potentiometer. See, because that one is connected here to the stage of the detector, and the wiper of the potentiometer here is going to the grid of the 2A5. So this is actually the volume control. I'm going to put it, yeah, it doesn't really matter basically because I don't have an input signal, but I just wanted to mention that. Let's see what happens. Big moment. We have 40 volts going in. That's not enough. Let's put a let's put a 25 watt tube in there. Now I have 100 volt going in, and we have something on the plate here. It's creeping up. 250, 260. I'm not hearing anything. 270? That's quite high. Okay, the other tubes are not in there, I get that, but... And I don't hear anything from the speaker. But it does mean that I get the voltage through. Let me plug it in here before. So that's the actual B+. See, that's 270 as well. So it is going through the output transformer. I'm having 131 volts going in, and I got a B+ of 276. Now, I don't know if you already should hear anything in the speaker and at this stage. There is nothing there, nothing at all. Now, I'm only putting in 130 volts, so it's definitely not enough, because, yeah, it's about half the voltage that you would expect on the input. But I can't go much higher, because my plate voltage here will be way too high, even though this datasheet says that maximum plate voltage is 375. But wait, I am measuring to ground now, right? That's not the same thing as to cathode. Yes. Let me reconnect this and we will check again. Okay, so this is now between plate and cathode. No, this is not between plate and cathode. This is between plate and cathode. So this is what is happening here. This is not good, I think. Okay, I think you might have spotted the problem already, but I have only spotting it now, so yeah, I don't know where my head was, but this is not correct, because now I have the cathode capacitor and the resistor in series, right? So these need to be put in parallel, obviously. Now, okay, let me fix this and we will test again. Okay, we're back in business. This is a lot better. See, I have now this capacitor, the cathode bypass cap between the cathode and ground. And then here, this is the resistor also between cathode and ground. This point here, I still need to heat shrink it. I will fix that. Yeah, if everything I've done here is correct. Okay, let's try this again. And I have again connected the multimeter to the plate of the 2A5. But now between plate and chassis. Okay, we again have 270 volts. It's not much of a difference. No, it's dropping now. Significantly. Is that normal? That could be normal, because that might be the tube that is actually starting to conduct. Okay, so let's try that again. See, it's dropping now. Let me add a 15 watt bulb. I now have 150 volt going in, 190 on the plate. The bulbs are not showing any shorts. 170 on the plate. Let's put in, how shall we do this? Just gonna turn it off. I'm gonna put a single 40 watt bulb in place. And it's glowing bright and it's dimming off. 40 watt, or I had, that's basically the same thing as what I had. So let's put in another 25 watt. We've got now 190 volt going in. This is actually looking healthy, but I can't hear anything in the speaker. 185 volt going in, 245 on the plate. This seems good. Let's add another 15 watt. I've got now 200 volt going in, 270 on the plate. This actually looks good, but I don't hear anything. I don't hear anything in the speaker. But voltage seems quite stable. See, I've got 264. Maybe we can now measure the plate to cathode. That should be here. Plate to cathode is 246. That looks quite healthy. Let's see what I have on the grid. that should be minus 16.5. Let me turn this off. So I'm now measuring between grid and cathode. Look at that. Minus 17, it's even slightly high. Let me do some measurements here. Let me check if everything in the speaker is hooked up correctly. And then I will get back to you. But all the voltages seem healthy, so that's already a good start. Okay, listen to this. Yeah, it's very silent, but there is a clear hum in the speaker. Let me get the microphone a bit closer here. Yeah, we have sound. Great. Amazing. Ha. Now, I don't know if everything is correct or not, or if it is low or high, or I have no idea. But at least we got sound out of this thing, which is fantastic. Now, I just hooked up my signal generator here between ground and the output of the volume control, so that's the grid of the 2A5. Let's put in a 1 kilohertz tone. Let's go to 1 volt RMS to start. Let's see what we get. Ah! Ha! Amazing! Wow. Let's go to 2 kilohertz. Haha. 400 hertz. This is 1 kilohertz. Now let's go to 2 volt RMS. Yeah, that's quite loud actually. Amazing. And I don't hear any hum at all in the speaker. So that means that the humbucking coil is correctly connected and working. And that means that, yeah, all my output transformer and my field coil are perfectly fine, working like they should. And wow, I'm really, really stoked. I can't believe that I just powered up a 90-year-old radio, which was completely gone in terms of, yeah, aesthetics and electronics and everything. Oof, this really feels like a bit of a victory. So yeah, that's really nice. So I think that's more than enough for this video. We've got the power supply working, we've got the output tube working. That's already really nice, and that's much more than I originally planned to do in this video. So really great. I'm really happy with this. What am I gonna do now? Well, I am going to it's washed out again. I'm going to reverse engineer this part of the radio, draw the rest of the schematic, because in the next video we're gonna start here and work our way to the left, because we have the next step is the preamp and the detector tube. So that's for the next video, and then we get into the IF stages, and yeah, you know. So I'm just gonna go ahead and draw the schematic here. So yeah, next video will be about that. And then the cabinet, I still have to start on the cabinet. So I don't think the next video will be about the cabinet, because that'll take a while before it's finished. And the problem is now as well, we have really bad weather here these days. So doing cabinet work is not that easy. It's way too cold actually to varnish. And in the garage it's also quite cold. And I originally wanted to spray the varnish on the cabinet, but I don't think that'll be possible because of the weather. But anyway, the cabinet is for later. Let's focus on the electronics for now. So next video will be the preamp and the detector. So yeah, I'd like to thank you for watching. I'm glad that you're following along with this big adventure of this tube radio. We made a huge step in this video, and yeah, I'm really happy. So thanks for watching. See you next time. Take care. Bye bye.